Okay, so what we're going to do now is start the maths content for electronics, but in order to do the math stuff well, we have to cover just a little bit of kind of solely maths content, things that will help us to do the jobs. One of the things that we'll have to look at one point is rearranging equations, how we change the subject of a formula. So we'll find all of our formula in the data book. The data book is in our team. Give it a wee second, I don't know why it's taking so long. Come on. There you go. So in our 3ESH team, or in whatever team it is that you're in that you're watching this, you'll find a copy of the data book. It should be in the files tab at the top of wherever your team is there. Yeah, there's the data book. In the data book, it tells you all the quantities, it tells you the equations that we use. If you're ever looking at something that you're unfamiliar with, your first protocol should be the data book to see if there's anything in there that jogs your memory. It's a relatively short document. You're allowed to have it in exams and assessments. It helps you remember the equations. Okay. So we'll have to be able to access those equations but also rearrange them. So like for instance, one of the equations that we use quite a lot is Ohm's law, V equals IR. That's how it's given to you in the data book. You need to know how to rearrange that to give you current instead of voltage, or how to rearrange it to give you resistance instead of voltage. Yeah, so that's rearranging equations. And what this particular we'll come back to that later, but what this particular presentation is about is significant figures. Significant figures. So this is all about how accurately we can reflect numbers, how accurately we would want to represent any value. Okay, so there's a couple of rules about what makes a number or a value significant. So let's look at the rules about significant figures. The rules about significant figures are any non-zero figure is significant. So that's 1 to 9. 0 has a bunch of special rules about it depending on where it appears in the number. It dictates whether it's significant. Okay. Any 0 in between any significant figures is significant. Let me just give some examples of this before I go any further. So if you've got the value 1, then we would say that that had one significant figure. If you had the value 32, then we would say that that had 2 significant figures. If you had the value 647, you're getting the picture hopefully, that's got 3 significant figures. Okay. Any 0 in between any significant figures is significant. So that means if we've got 304, that 0 is considered to be significant, so that's got 3 significant figures. If we've got 4001, that's got 4 significant figures. Okay. Leading zeros. Are never significant. So a leading zero is a zero that's written at the start of a number. Now, most times you're never going to see leading zeros unless you've got a decimal point, but you know, just in case, let me move my wee face again. Just in case, let's look at an example. So if you've got 000427, that's only got 3 significant figures. If you've got 0.000427, that's only got 3 significant figures. These are both sets of leading zeros, zeros that are drawn, or zeros that are written before the rest of the number. Leading zeros are never significant. With the opposite of leading, this brings us to trailing zeros, and there's a rule about this. Okay, this is where it gets a bit weird, and this is where you'll get tripped up, because I think everyone up to this point has been fair enough, but this is where it gets difficult. Okay, trailing zeros are only significant after a decimal point. Okay, so 42, no decimal point, has got 2 significant figures. 42.0 has 3 significant figures. Right. $420 has only got 2 significant figures, because trailing zeros are only significant after a decimal point. There's no decimal point in here, so that 0 is insignificant. So that's only got 2 significant figures. Okay. You notice the trailing zeros are the things that cause the problem. Up here, it looked like the number of significant figures was just however many numbers you wrote down. If I've written down 3 values, a unit, a 10 and 100, then I've got 3 significant figures. That's only true if, you know, depending on the zeros and the decimal points, because here I've got a unit, a 10 and 100, but that 0 is considered to be insignificant, so that's 2 significant figures in that 3-digit number. If I put a decimal point in, what happens to it? So 420.0, how many significant figures has that guy got? So suddenly that decimal point, that 0 is significant. It's a trailing 0, but it's after a decimal point, so it's significant. Well, this guy, he's not a trailing 0, because he's not at the end. Also, he is now in between a significant figure and a significant figure, so suddenly that 0 is significant. Notice he wasn't significant there, but because we've got a significant figure after him now, he is now considered significant. So that number actually has 4 significant figures. That's pretty much the extent of the rule as far as we're concerned. It is possible to write a number that looks like that, where the intention is that it's got 3 significant figures in it. And in a lot of instances, some stated values have what are considered to be an infinite number of significant figures, but we'll talk about that when we get to questions that have them in it. This is the general rule for significant figures. Okay, what I'm going to do is I'm going to put up a quiz for you to do on the subject of significant figures. It includes a little bit of rounding to significant figures. Now, hopefully you're already confident with the concept of rounding. That is, if you've got 45.2 and you want to round that to get rid of that decimal point, the question is, if this is the number that's disappearing, that's fine, he's going, right? The question is, does that guy stay a 5 or does he become a 6? And the rule is, If this is either 0, 1, 2, 3 or 4, he stays a 5. If he's 5, 6, 7, 8 or 9, he goes to a 6. So that rounds to 45, whereas that rounds to 46. Hopefully you already know that, right? As far as significant figure rounding goes, it's the same kind of process. So if you've got a number like that, that's got 3 significant figures in it. If somebody asks you to round that to 2 significant figures, what it means is you keep the most significant, the ones to the left. So what we're saying is these guys are going to become 0 because they are no longer significant. We're keeping the top 2 as described in the question. So they are definitely going to be 0. That guy's going to be unchanged. And then the question is, does that 7 stay a 7 or does it become an 8? Well, that's a 5, so it becomes an 8. So 3, 7, 50 rounded to 2 significant figures means that the insignificant ones become 0, the most significant one's going to stay, and then we've got a question mark over the one at the boundary. And that's the kind of process. So again, let's do another one. Let's do 42.04. And let's round that to 3 significant figures. Round to 3 significant figures. So how many is there? There's 4. This one's going to become 0. This is the one at the boundary. The question is, does that stay a 0 or does it go up? And then they two remain unchanged. Technically that's got 4, so you would write it as that. So that's 42.04 rounded to 3 significant figures. Okay. We'll do one more. Let's go 0.002750. That's got, how many significant figures has that got? Do you know? These are leading, they are insignificant. That one's in between, so it is significant. So we've got 1, 2, 3, 4, 5. This has currently got 5 significant figures. Let's round it to 4. So 4 significant figures, that's still going to be there. 2, 7, there's my first 3 significant. Does this stay a 0 or does it become a 1? It stays a 0. Let's round it to 3 significant figures. 0.0027, does that stay a 5 or does it become a 6? It stays a 5. Let's round it to 2 significant figures. 0.002, this is the boundary, does that become an 8 or does it stay a 7? No, because that's a 5, it becomes an 8. Let's round it to 1 significant figure. 0.00, does that 2 stay a 2 or does it become a 3? It becomes a 3. So this is how we round to significant figures. Okay? And that's what's going to be in the quiz. There's a bunch of examples and an explanation. Oh, these are the rules that you need to apply. If you want to watch this a couple of times, write down those examples, make sure you understand them before you do the quiz.